with blue lines, you have subduction, where the difference is getting less. And if you add all these centimeters with negative sign, the subduction, then in the average at the equator of the Earth, you have about 19 centimeter. The Earth is growing in the circumference year by year, about 19 centimeters.
That's fascinating.
Yeah,
that is fascinating.
And it's able to be measured very exactly because using satellites. And so nowadays we have possibilities at the time of Tesla we had not. And so these measurements are very exact on one hand. And now we have two possibilities to explain why the Earth is growing. One possibility is that the density is getting less. So the Earth would grow with a constant mass if the density is reducing. And, well, on the other hand, if you have a turning ball, and this turning ball is getting bigger, then you know that it is turning slower and slower. That is a consequence of the angular moment and impulse, turning impulse. Yes.
So that would, well, Doctor, that would explain what the hollow Earth, that the Earth is hollow?
No, it has nothing to do with the hollow Earth. If you have a ball, if it's fulfilled or hollow, it doesn't matter. If the ball is getting bigger, then it's getting slower. So this is a consequence in physics. And this means that we are able to measure the time, because we have very exact possibilities to measure the turning time by atomic clocks. And the best atomic clock we have in Germany is driven by the Physikalisch-Technische Bundesanstalt in Braunschweig, and this clock is controlling all the clocks in Middle Europe. So by long waves they are controlled. And this clock is very exact, and this clock is showing that the Earth is turning slower about 1 second a year. It is exactly in the average of the last 50 years, the time they are using this clock. They have measured about 0.73 seconds per year or something like this. And if you take this slowing down, this time difference, you are able to calculate what this time difference influences the growing of the Earth.
Okay.
And then if you calculate this, you find out if the density is getting less, then the growing should be 50 centimeters. And this is much more than they measure. So this is the wrong way. This is the wrong approach. And you have proved, because you know that you still have an influence from the moon, which is slowing down the Earth as well. But if you calculate this, you find a lot of calculations how the moon is influencing the Earth, and this is 1,000 or 10,000 times less. So this the influence may be neglected, you see. Of the moon. Here, another thing is slowing down the Earth. And now we have a second possibility. And the second possibility is that the mass is getting more and more.
Yes.
And if you put the density of the matter constant, and if you calculate that the mass is getting more and more, then you are able to calculate the effect, and you find out that the effect is 19 centimeters per year in the circumference, and this is exactly the value they have measured.
Uh-huh.
So we are able to prove, because we measure two things. We measure the time, the turning of the Earth, and we measure from satellite the size of the Earth. And if these two things fit together, and they fit together if the mass is getting more and more, then we know that this is the right answer and the only right answer. Well, I explain it in this way because Paul Dirac, the very famous physicist Paul Dirac, said that the density was getting less. And at his time, he couldn't prove. But nowadays, we are able to calculate, and we see that Paul Dirac was wrong with his approach. So this is very important, that we see that the mass is getting more. But if the mass is getting more, we have some effects. One is that at the time when the dinosaurs were living, how to pronounce it? Dinosaurs? These big animals. How do you pronounce
the dinosaurs?
it? Yes, the dinosaurs. Okay.
Yes.
At that time, the Earth had been smaller, and the weight of these animals had been less. Right. And this is why if you can't have these animals today, because the bones would break under the weight.
Yes.
80 tons perhaps. And this is, I would say a hint that the Earth is growing, and 60 million years before the Earth had been much smaller.
Mm-hmm.
But on the other hand, we are able to calculate all these things, and this is very important. And, the question at this point we have is, where is the mass coming from? And all these points, the German TV has produced these documentation film, which in English has the title "Turning the World on Its Head." And this film had been shown in the German TV on the ZDF for about two dozen times, and has been shown as well in France, and in the Russian TV and the Poland TV and the Arabian TV, but I don't know whether it has been shown in America. But I still have these English version, and the ZDF Enterprises is the company. They sell this film. And
Doctor, yeah, we're gonna take a short break here.
Yes,
and we'll be right back.
Okay.
Okay. Thank you. Hello, everyone. This is Dr. Houdini, and you're listening to the Progressive Technology Hour. And I have a very fascinating returning guest today, Konstantin Meyl. And we're talking about the expanding Earth theory and how neutrinos being emitted by the sun are interacting with the Earth's core. And in the first half hour of the show here, Dr. Meyl laid out, how this interaction is occurring. But, the real question is why is this occurring with the sun? And, in the movie 2012, they talk about a massive flux of neutrinos coming from the sun, causing massive, incredible Earth changes. And, back in 2005, I first became involved in this expanding Earth theory when I woke up one morning and knowing, I had this dream, this very bizarre dream that the Earth was growing. And, when I woke up and I says, boy, that's odd. What a strange dream I had. And then I went to the computer here and Googled, expanding Earth. And all this information came up, that I personally I'd never heard before. And I started researching it and getting into it. And I ran across a researcher by the name of Neil Adams. And I had him on my show several months ago. And he put together some very fascinating animations that of various celestial bodies referred to by Nikola Tesla that were growing in size. And he did these fascinating animations of the Earth, the Moon, Mars, and some moons, I believe, around Jupiter. And he was showing how the increase in mass and in size, and as they pull apart, creates continents. And we see that, the Earth, if you wound back the clock 250 million years ago, all the continents would fit together. But they only fit together under a smaller Earth. And at that time, the Earth was ruled by the dinosaurs. Okay, and of course, as I stated, the Earth was much smaller then, and all these continents, they all fit together. And then over time, the Earth grew in size, increased in mass, and we were just talking about this with Dr. Miles and about a program, a television program dealing with this subject. And Dr. Miles is wondering if we can pick up on that right now. Could you go into more detail about this television program?
Well, hello?
Yes, go right ahead.
I go ahead. Yes, the problem we discussed, which is discussed as well on this TV film, is where is the mass coming from, which lets the Earth grow. And, Einstein says that mass and energy could be the same. That means that if energy is radiated into the Earth, then this could be a possible answer. But where is the energy coming from? And now we know that the neutrino flux is interacting with the core of the Earth, and this could be a possible answer. So what we need in physics is a model. We need to explain what happens. And I do the following experiment with my students. I ask them, what is your weight in the center of the Earth? And sometimes I get the right answer, that the weight is 0. There is no gravity. So this is the same situation you have in space. If you take a mixture of solid matter, of liquid matter, of gas, and so on, then at the end you get several levels. The bottom level will be the solid state, which is the crust of the Earth. And on this crust you have the liquid matter, and then which is the water, and then you have the gas, which is the atmosphere. Well, it's all up to the density of the matter, This is what we learn at school. And outside the atmosphere, the gas, we have the ionosphere, which is something like a plasma with charged particles, and outside the ionosphere there is the space. And there we have no gravitational force. and zero gravity.
Well, doctor,
yes.
yeah, let me stop you right there. Has any experiment